All right, hello everybody. Today we're getting into Objective 2 of our Algebra B review, dealing with exponents. Big thing we're going to do today is go through a bunch of different properties of exponents, show you how they work, okay, important stuff that's going to show up for you as you continue all through math. Okay, so let's get going here. Now, let's begin by reviewing exponential notation for you. When I say x to the nth power, what that means is that I'm going to take the x and multiply it by itself n times. Okay, so x to the n means x times itself n times. Now, vocab for that notation, we'd say that n is the exponent and x is the base. Okay, so for example, if I have 2 to the 5th power, that's going to be equal to 2 times 2 times 2 times 2 times 2 5 times. And I suppose I can do this in my head. 2 times 2 is 4, times another 2 would be 8, times another 2 would be 16, times another 2 would be 32. Okay, so we'd say 2 to the 5th is equal to 32 because 2 times 2 times 2 times 2 times 2 is 32. Now that simple definition is going to lead to a whole bunch of different properties that we're going to go through today. And we'll begin looking at some properties for multiplying and dividing numbers with exponents. And starting off with multiplication, we'll say to multiply powers with the same base, you add the exponents. So here, we'd say that if I have a to the m times a to the n, the same base raised to two different exponents multiplied by each other, this says the result is going to be a, that same base, raised to the m plus n. In other words, add the exponents together. Okay, well, why is this true? Let's say I have x squared, and I'm multiplying by x to the third. Okay, well, what is that going to be equal to? X squared means x times x, and x to the third means x times x times x. Okay, how many x's do I have here? 1, 2, 3, 4, 5. I have 2 plus 3 x's. That's why we can say it's x to the 2 plus 3. Okay, because adding those exponents results in adding the number of times we're multiplying. In other words, we have x to the 5th. Okay, what this property is going to allow me to do is jump straight from kind of x squared times x to the third to x to the 5th, again by adding those exponents together. Now we have a similar rule for division. To divide powers with the same base, subtract the exponents. So if I have a to the m divided by a to the n, where once again a is my same base for these, what I'll do is my result will just be a, that same base, to the m minus n, okay, top exponent minus the bottom exponent. Okay, why is this true? Let's say I have x to the 5th, and I want to divide that by x to the third. Well, by definition, what do I have here? X to the 5th is x times x times x times x times x 5 times. And x to the third is x times x times x 3 times. And no, by division, if I divide x by x, the x's cancel out. So essentially what I'm going to do is I'm going to cancel 3 of the x's from the top 5 with 3 from the bottom. I almost forgot one there. And that's where the result's coming from. X to the 5 minus 3, okay, minus because we're canceling, is going to give me an x squared. Okay, that's the 2 x's we had remaining at the end. Let's go ahead and put those properties to work here, starting with the multiplication property. Problem 1 says, what's the simplified form of each expression? And I have an expression where I'm multiplying some different factors together. And what I want to do is I want to make this as simple as possible by combining as many exponents as possible, combining the constants, and coming up with just the easier to work with expression. Okay, now, first thing I can do for this is, notice I have 3 factors being multiplied together. I can just multiply the numbers together. I can go 3 times 9 times 2. So we'll kind of group that together. And I can also multiply my bases to the powers. Now for this one, a squared and a are the same bases. I can combine those. I can't combine them with the b at all. Okay, the b is just going to be by itself here. All right, now as far as combining the exponents with the a's, I can think of this second a as a to the first power. So we can write this as a to the 2 plus 1. And then times, like we said, this b here, we'll just write as the b. Okay, putting everything together then, 3 times 9 times 2 is just going to be a 54. A to the 2 plus 1 would just be a to the third. And b, we can think of this as b to the 1. We don't need to write to the 1, we'll just write it as a b. We'll say this is my simplified form here. Okay, simplified because I've multiplied all the numbers together as possible. And for each of the variables, they only show up once now. I have one factor with the a in it, one factor with the b. Okay, that's how we'll know things are simplified. All right, problem B is the same idea. Why don't you take a minute, pause the video, work through problem B, and then hit play and we'll work through the answer together here. All right, let's go ahead and run through part B. So once again, we can start by multiplying our constants, and I'll just do that in one step here. 4 times 3 times 2 is going to give me a 24 for my constant factor. And then I'll be able to combine the c's. Here I have a c to the first power times c to the third, so we can write that as c to the 1 plus 3. I can also combine my d's. I have d to the fifth times d squared. We can call that d to the 5 plus 2. And that's going to simplify into 24 c to the fourth, d to the seventh when I do that addition. And again, I know this is simplified because all my constant terms are multiplied. Okay, there's only one factor with the c, one factor with the d. We call this simplified form here. All right, next up, let's go through some problems involving division. Okay, remember to divide numbers with exponents, we will subtract the exponents. Okay, so first off, I can do the 6 divided by 2. That's just a 3. Same thing with the multiplication. Just divide those constant factors. And then for the x to the 8th divided by x to the third, I can rewrite that as x to the 8 minus 3. And once again, it's minus because 3 of the x's on the bottom are to cancel with 3 of the x's on the top. We'll subtract those away. And once again, I have a y by itself. No other bases to combine that with. No other base y to combine that with. So we'll just say y at the end. Okay, so my final answer here will be 3x to the fifth y. That'll be as simple as we can make this one. All right, so there's a division example. Why don't you pause the video, work through part B in the note guide, and then press play again to check your answer. All right, let's go ahead and run through part B now that you've worked through it. Here there's no constant terms to do division with, so we'll just jump straight into our exponent in pieces. I've got m to the fifth on top, m squared on the bottom. That's going to be calculated as m to the 5 minus 2. Okay, times for the n then, n to the fourth divided by n to the third, we can say is n to the 4 minus 3. And reducing that down, 5 minus 2 is 3, so we have m to the third. Okay, n to the 4 minus 3 is just n to the 1. We'll just write it as a 1. Or just n, okay, without the 1 here. If you put the 1 there, it's technically not correct, but it's more than we need. All right, so m to the third n is as simple as we can make that one. Next thing we're going to talk about are a few special cases for exponents, a few of the special properties. Okay, dealing with zeros as exponents and also negative exponents. Starting off with the 0, we're going to say for any non-zero number x, x to the 0 equals 1. Okay, so for example, we could say that 7 to the 0 is equal to 1. All right, x to the 0 is equal to 1. Okay, anything raised to the 0th power is just going to be equal to a 1. All right, now why is that true? Well, let's do some division. Let's say I have x squared divided by x squared. Okay, I know when I divide something by itself, I get a 1 here. And when I do my calculations with my exponents, that's going to be equal to x to the 2 minus 2. In other words, x to the 0th power. In other words, we're going to say 1 by definition. Well, that makes sense because, again, when I divide something by itself, I know I get that 1. Because that's kind of why that rule works the way it does. All right, next thing we're going to talk about are negative exponents. We'll say for every non-zero number x and integer n, x to the negative n is just equal to 1 divided by n. Okay, meaning that, for example, if we have 3 to the negative 2 power, that's going to be equal to 1 over 3 squared. Okay, or in other words, 1/9. All right, so what I do with that negative exponent is to make it positive, I will flip my base to the other side of the fraction, and then I can evaluate it as a positive exponent. Right, so let's go ahead and go through a few problems where both zero exponents and negative exponents show up for us. Now, we're not going to have any special problems that are only about zeros or only about the negative exponents. Okay, they just kind of mix in with the other types of questions we've looked at. So, for example, problem 3, part A, what's the simplified form of the expression once again? Notice I have some negative exponents right off the bat. What I'd recommend to do is not try to do subtraction with negatives. I'd say use that negative property right away and flip these two exponents around. Okay, x to the negative 2 is going to be the same thing as 1 over x squared. And then 1 over x to the negative 5 is going to be x to the negative 5 on top. Okay, so again, I'd recommend get rid of those negative exponents right off the bat there, flip them around, and then we can deal with the rest of the question here, reducing things down just like we did a few minutes ago. Okay, so I can reduce this down to then x to the 5th divided by x squared. We can write that as x to the 5 minus 2. Okay, times y to the 4th over y to the 4th will be y to the 4 minus 4. So that's going to be our 0 exponent here. And then z to the 8th over z to the 1, we can just say it's z to the 8 minus 1. So this will all reduce down to then 5 minus 2, so that'll be x to the 3rd. Okay, we can call this piece here y to the 0, which equals 1. I don't need to include that in my final answer. And then z to the 8 minus 1 would just be z to the 7th. All right, there's my simplified answer here. And I'd call it simplified because we've combined all the constants, we've combined all our variables, and then we got rid of these negative exponents. You don't want to leave negative exponents in your final simplified answer. Okay, part B is the same idea, dealing with negatives, dealing with zeros. Why don't you take a minute, pause the video, run through part B, and then again hit play to check your answer. All right, let's go ahead and run through part B. Once again, I'd recommend move anything with a negative exponent around right off the bat. Okay, so as far as this one goes, this a to the negative 3, I'm going to write that as a to the positive 3 on the other part of the fraction. There'll still be the b squared up top, and then we'll have the a to the 5th over b to the 7th here. And as far as combining for these ones, I can think of my numerator combining these b's here as having a b squared, or b to the 2 minus 7, just subtracting these. And I can tell that's going to give me a negative exponent, okay, because the bigger exponent's on the bottom. And then on the bottom, how I can think of this is just as a to the 3rd plus 5. Okay, since those are both on the bottom, I can make the combination of them on the bottom here. Okay, that's going to result into a b to the negative 5th over a to the 8th. And if I move that b back down, I'll just have a 1 on top over a to the 8th, b to the positive 5. Again, I'd say this one's simplified. Okay, all the variables are combined, and all my exponents are positive. Okay, finish this one off by moving any negative exponents to the other side of the fraction. Next thing we're going to talk about are some multiplication properties of exponents. Okay, and we have three of them. First one says that to raise a product to a power, raise each factor to that power and multiply. So here, if I have the quantity of a times b to the nth power, that's going to be the same thing as a to the n times b to the n. Okay, so you can think of this as kind of distributing that n to everything within those parentheses there. Why does that work? Well, let's say I have 2x to the third power. Well, what is that equal to? By definition, that would be 2x times itself 3 times. And if I just rearrange things, if I put all the 2's together, 2 times 2 times 2, and all the x's together, times x times x times x, well, how can I rewrite that? I have 3 2's, so we could say 2 to the third times 3 x's, which would be x to the third. Okay, I could obviously simplify that further. But that's how we can see kind of that exponent going to both parts here. Okay, both the 2 and the x of the x get raised to that third power. We also have a similar rule for raising a quotient to a power. We'll say to raise a quotient to a power, raise the numerator and denominator to the power and simplify. So if I have a over b all raised to the nth power, we can just distribute that n to the a and to the b. Okay, so it goes to both the numerator and the denominator to give me a to the n over b to the n. So similar problem, if I have 2 over x all raised to the fifth, that's just going to be equal to 2 to the fifth over x to the fifth. Okay, I'll raise both the numerator and the denominator to that power. All right, and the last property for today, okay, raising powers to powers. So to raise a power to a power, you just multiply the exponents. So a to the m raised to the n power is just going to be equal to a to the m times n. So for example, if I have x squared to the third, well, what's that equal to? X squared to the third will be x squared times x squared times x squared. Okay, multiplying by itself 3 times. Okay, we know how to add these together. That'll just be x to the 2 plus 2 plus 2, adding those exponents together. Okay, so here's where we get kind of those 3 groups of 2's here. In other words, we end up with the x to the 6th. All right, so again, when you're raising powers to powers, you're going to multiply those powers together. Let's go ahead and use those multiplication properties here. And we'll just try to kind of run through 3 questions that demonstrate each of them. So the first one, what's the simplified form of the expression? I've got 3ab to the fourth, all raised to the second power. Now what we said is that to make that happen, you're going to distribute that 2 to all 3 parts here. Okay, so that's going to give me a 3 squared. And come test time, come quiz time, the thing a lot of students are going to miss is you're going to miss distributing that to the constant factor. So don't forget that. All right, times a to the, now since there's just an a, we can think of it as an a to the 1. A to the 1 times 2, which will just be a 2. And then times b to the 4 times 2. So in other words, we're left with 3 squared, which is 9, times a squared, okay, times b to the 4 times 2, which would be b to the 8th. All right, we'll say that's the simplified form of this one here. All right, now multiplying exponents are going to work out the same way when we have a quotient. I'm going to take this exponent and distribute it to both the numerator and the denominator. Okay, so that's going to leave me with a 2 to the negative 3 power. We'll talk about dealing with that in a minute. Okay, times x to the 6 times negative 3. Okay, over y to the negative 2 times negative 3. Okay, let's go ahead and start reducing this down. Now 2 to the negative third Remember, our negative exponents mean flip things to the other side of the fraction. So I'm going to flip that right away. I'm going to make that a 2 to the positive third on the bottom, okay, dealing with that negative exponent. Okay, x to the 6 times negative 3, that's going to be x to the negative 18 power. And we'll flip that in a second here. And then y to the negative 2 times negative 3 is just going to be y to the positive 6 on the bottom. Okay, just like multiplying normal numbers together, negative times a negative makes a positive. Okay, so just because they're exponents, they are going to work the same, so we get y to the 6th on bottom. Okay, to finish reducing this down, I want to get rid of my negative exponents. I also want to evaluate if possible. Okay, 2 to the third I know is 8. That's just 2 times 2 times 2. X to the negative 18 is going to be the same thing as x to the positive 18 on the other side of the fraction. And then we can leave the y to the 6th on the bottom. Now once again, if there's nothing left on the top, we'll just call that a 1 on top. Okay, so we'll say this is simplified as 1 over 8 x to the 18 y to the 6th. We'll call that simplified form. And last thing we're going to talk about in this lesson is scientific notation. Okay, scientific notation is one of the many nice practical applications of using exponents and their properties. Okay, we could use those to add numbers, subtract numbers, multiply them, divide them in scientific notation. Okay, we're just going to work on today, though, just converting back and forth between standard form, like I see on the left, and scientific notation on the right. Okay, we're just going to say scientific notation are numbers written in the form a times x, a times 10 to the n power, where n's an integer, and a is between 1 and 10. Okay, so for example, instead of writing 830 million out like this, we could just call it, in scientific notation, 8.3 times 10 to the 8. Okay, if these two numbers mean the same thing on the right side, it's a little bit easier to work with. So let's write some numbers in scientific notation. Part A, we want to write the approximate distance between the Sun and Saturn, which is 1,430,000,000 kilometers. Oops. Get that out of the way here. Okay, to do that, I'm going to take the number part here, the 1.43, and we'll write that as times 10 to some power. And what the power is going to be is I need to think about what's it going to take this 1.43, if the decimal's here, and move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Okay, well that's just going to be times 10 to the 9. And the reason we use 10 for that base in our scientific notation is it's really easy to move decimal places by multiplying by 10 or dividing by 10. All right, let's look at another example. This time we're writing a really small number in scientific notation. So the radius of an atom, we'll say, is 0.000000, I don't even know what this number is, meters. In scientific notation, we could call that a 1.0 times 10 to the, and if I want to move my decimal in the other place, if I want it in the other direction, if I want to make this really small, we'll make it a negative exponent. And if our point is right here and we want to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left, we'll just say our exponent is negative 10. Okay, so 1.0 times 10 to the negative 10 would move that decimal place to the right spot there. All right, there's also a part C for this one. Why don't you take a minute, pause the video, work through that, and then hit play to check your answer. In C, we want to write the population of California, 39,500,000 in scientific notation. We'll write that as 3.95 times 10 to the, let's see, if my decimal place is here and I need to move it to the right 1, 2, 3, 4, 5, 6, 7 times, we'll say 10 to the 7th power. All right, there's my answer in scientific notation. Okay, last thing we're going to do is look at going in the other direction from scientific notation to standard form. So let's show you how to do this. So 5.5 times 10 to the 6th is going to take that 5.5, I'll actually make my decimal place a different color here, and multiplying by 10 to the 6th is going to move that decimal place 6 positions to the right. Okay, so 1, 2, 3, 4, 5, 6. And what we'll do is we'll put zeros kind of in between each of those spaces it moved. All right, so I could write this as 5, 5, 0, 0, 0, 0, 0. We'll fill in our commas, and we ended up with 5,500,000 grams for this one here. All right, one more time today. Pause the video, work through part B, and then hit play to check your answer. All right, last conversion. Weight of a truck, 2.8 times 10 to the 6th. We'll take the 2.8, and we'll move that decimal place 6 times. 1, 2, 3, 4, 5, 6. We'll put zeros in between each of those spaces we moved. And we can write that as 280000 with the decimal place at the end.